Welcome back. What we're going to talk about today is a way to sort of graphically represent our data using what I sometimes will call a graph, but is technically called a figure in psychology. So what we're going to talk about today is a thing called a frequency histogram. Okay? Frequency histograms are just graphic ways of representing our data. The first thing you have to understand is the basics of graphing. So in a graph, there are two axes. And the general rule for any sort of frequency graph, right, is the frequency goes on the left. So this is the frequency, F. And then down on this end go the scores. Okay, the other rule for frequency histograms and graphs, and really the rule for all graphs, is that this point down here, the origin point, should always be the lowest value. So the lowest values go here. That means that for the frequency it'll be 0, and then for the scores it'll be 0. Okay? So let's do this. Scores go down here. Okay, let's go back to our quiz scores because those are fairly easy. Okay, you can do this with either grouped frequency tables or you can do it with non-grouped frequency tables. I'm going to talk about non-grouped data because that's how I tend to sort of think about these things. So over here again is the 0, 0 point. So 0 frequency and 0 score. You want to divide these up evenly. This would work a lot better if I had graph paper, but I don't, so just sort of stick with me. Okay, and then scores go down here. Let's say it's a 5-point quiz, so we'll put five options, or 5 scores down here. Okay. So once you get your variables or your graph set up, then you can go in and start putting in your scores. So let's say that nobody got a 0. So we had a good quiz week. Okay? And let's say 2 people got 1s because they did not study. Okay? Yeah. And then, so these bars actually touch. For 2s, let's say one person got a 2. Let's say one person got a 3. Let's say 3 people got 4s. And then for 5s, let's say that 4 people got 5s. So the reason why this is called a frequency histogram as opposed to a bar graph, and this is 100% not bar graph. Is because these scores, right, sort of flow into one another. Okay? So there's a sort of continuous motion between them, right? Between the 3 to 4 and the 4 to 5. It's sort of hard to explain. But in a bar graph, which I will go ahead and sketch for you briefly, but this is not a histogram, this is a bar graph. In a bar graph, you might have frequency over here, right? But down here you would have separate categories or conditions. This is bar graph. Okay? So how many people came into Starbucks versus Dunkin' Donuts, okay, on Monday morning or something. Here, there is no sort of scores down here, right? That doesn't make any sense. So here you would have 2 separate individual bars that are broken apart. And over here you can still have frequency. That's fine, I guess. 1, 2, 3. These are like the most boring Starbucks in the world. So at Starbucks, 3 people come in on Monday morning, and at Dunkin' Donuts, only 1 person comes in. Okay? These two are separate categories, and henceforth, the bars don't touch, right? They're separate categories. So there's a big space in between the bars, or a small space, but there's a space between the bars. Okay. Another thing you can do with a bar graph, and you guys probably remember this from high school, right? This again is a bar graph. Okay, is you could over here put like average test score. And we use bar graphs in psychology. They're just not the same as frequency histograms. Okay, and then down here you might have, let's say this one is 50%, and up here is 100%, and then down here is 0%. Excuse my category, my spacing isn't very good there. And then down here you might have men, and down here you might have women, and you might compare them. So let's say that men got like 95 or something like that, and then women got like a 98. And you would do a bar graph for that. Now, one of the reasons why we use frequency histograms is it allows us to see the shape of the data, or the shape of the distribution. And this is really useful because it allows us to see, is everybody scoring at one end of the distribution? Is everybody doing really, really well on the exams? Is everybody doing really, really poorly? Is everybody about in the middle? And you can tell that really fast just by looking at a graph of the distribution of scores. All right, so the next thing we're going to talk about is called a frequency polygon. Okay, so frequency polygons follow a lot of the exact same sort of rules as you would have for a frequency histogram. The difference is that for a frequency histogram, scores are going to go down here, frequency is going to go here. For frequency histogram, we had those bars. It wasn't a bar graph again, but it had bars. In a frequency polygon, poly means many-sided figure. What we will have instead of those bars is, so let's go back to our quiz scores, right? So 0, 1, 2, 3, 4. And then down here, our scores again. So our score 0 will be there. Here's our score 1. Here's our score 2, here's our score 3, here's our score 4, here's our score 5. Okay. What you'll do for this type of graph, in a way it might be sort of easier, is that you will put, mark where the scores fall on the actual sort of paper, and then you basically connect them so that it looks like a line graph, but it's not a line graph. Okay, we'll talk about line graphs in a minute. So let's say that 2 people got a 1, 1 person got a 2, let's say 4 people got 3s, 4 people got 4s, and 4 people got 5s. This was a bigger class than the other class. What you'll do then is you'll just sort of connect them. You always want to connect to this axis, right? So the horizontal axis. You always want to touch on that, but because there's nobody actually scoring 0 here, what you use is sort of a dotted line to get you started. And then from here, you can connect them with lines. Okay? All right, so let's talk about why this isn't a line graph. Line graphs in psychology are used to show the passage of time. So in other words, as things change over time, the lines sort of move up and down and so on. And I'll give you an example just so that you have an example, but again, this is not a frequency polygon. All right. So this is Joe's test scores. Okay. All right, take two. Sorry. So down here, okay, we will have some sort of time unit normally. Okay. So let's say this is day of school. That says day of school. So this is 0 days of school. 1, 2, 3, 4, 5, 6, 7, 8, and so on. And then over here, let's say this is some unit of like reading speed. And let's say that this is 5 words a minute, 10 words a minute, 15 words a minute, 20 words a minute. I don't know anything about reading speed. But let's say that down here, this is days of school, and we want to illustrate that as the days of school go on, the reading speed increases. So on the first day of school, we get some sort of measure of his reading speed. It's 15 words a minute, and at 2, it's 15 words a minute, and then at 3, for some reason, it drops, and then it drops at 4, and then for some reason it bumps up over here, and it stays high over here. And generally, you just sort of connect the points, okay? And the idea is that as you're sort of following this line, right, you're seeing the passage of time. And line graphs are really good for that, but again, this is a line graph. It is not the same as a frequency polygon. All right, so we talked about two different types of figures and graphs, right? Frequency polygons, which will look something like this. Okay, it's a many-sided figure with the frequency here and the scores down here. And we talked about histograms. Histograms, we have what look like bars. We talked about them not being bars, something like this, with frequency over here and scores down here. There are rules about when you use each one, but we're not going to focus too much on them. And when we actually do these types of graphs where we're sort of quickly sketching them out, you'll see me do something that's actually sort of neither, and I'll show that to you right now. Clear off the... And so what I tend to do when I'm illustrating data really sort of quickly is we'll just say something like frequency here and score here, and then this is 0 and this is 100 or something like that. And then down here the scores of 0, 10, 20, 30, 40. And then you'll see that I will draw quickly a curve or something like this that sort of illustrates where the data falls. This is something that we do sort of informally. It's very rare that you'll see it actually sort of published someplace, but a lot of times mathematicians will use it as we try to illustrate data quickly. And we sort of, even when we have a bar graph or a frequency histogram, a lot of times we'll overlay or we'll talk about it as a curve. And we're sort of talking about this sort of line that looks sort of like a wave that you can sort of superimpose over top. All right, well, thank you very much. I will see you guys in the next video, which will focus on shapes of distributions.